Alright, in this video we're going to work through the literal equations foldable. So first I want to make the foldable. So you do that, you take these two pieces of paper, you line this literal equations up here so you can read the question, what is a literal equation, below it. And then you're going to fold it over so that these line up just like so. Fold it down, and then we're going to staple, use the stapler, staple so that we can still fold it open, but that these stay together. Okay, so we have our literal equations foldable. The first thing that we need to talk about is, what is a literal equation? So if we fold this up, we're going to talk about what a literal equation is. Now we know an equation means an algebra or a mathematical sentence that has an equal sign. So we know a literal equation will be an example of this. There will be an equal sign, but more specifically, we will also see two or more variables. So a literal equation is going to be an equation, meaning we'll see an equal sign with two or more variables. To solve a literal equation for one variable, we use inverse operations, just like we did when we were solving equations with one variable. When I say inverse operations, I mean addition is the inverse of what? Subtraction. And multiplication and division are inverses of one another. So addition and subtraction, multiplication and division, they are inverse operations of one another. So let's first talk about how do we do this for one-step equations. So if you open this up, you have solved one-step equations already. So let's look at this equation, x plus 7 equals negative 12. Pause the video and solve the equation for x right now. And solve this equation for y. Go ahead and do both of these equations right now. Now that you've solved this on your own, let's go ahead and talk about it together. When it says solve for x, that means my final answer is going to look like x equals. X is a variable that I'm isolating. And if I'm going to do inverse operations, that means I have to look at what's going on between x and 7 and do the inverse. So if I have x plus 7, subtracting 7 will be the inverse. 7 minus 7 adds to be 0, so you're just left with x. And on the right-hand side, negative 12 and negative 7 can combine to be negative 19. Whereas over here, if I'm wanting to solve for y, that means my final answer will look like y equals. And in order to get y by itself, I do the inverse of subtracting 9, which is adding 9. These will add to be 0. I'm just left with y on the left-hand side. And on the right-hand side, 34 plus 9 would be 43. And so I have my two solutions. Those are equations that you've already solved in the past, but now we are moving on to doing it with literal equations, meaning two or more variables. So in this case, we see three variables. We're solving for a. So I'm going to circle the variable I'm solving for. It means I need to get a by itself. This looks very similar to the previous one where I was solving for x. But instead of adding 7, I'm now adding b to the variable I'm trying to solve for. So I have to think to myself, well, what can I do to isolate a? I have to do the inverse operation. Well, the inverse of adding b would be subtracting b. So I can subtract b from both sides. Negative b and a positive b will add to be 0, or the inverse operations undo one another. On the left-hand side, I'm left with a. On the right-hand side, I cannot combine the c and the b. They're not like terms, so I'm just going to leave my answer as c minus b. Another way you could write your answer as negative b plus c. Either one of these will get full credit. Go ahead and try number 2 on your own right now and pause the video. Now that you've tried 2 on your own, let's talk through this together. If it says solve for d, it means d is the variable I want by itself. So I need to move this minus e. I somehow need to eliminate that. Well, if I'm subtracting e, if I do the inverse, I will be adding e. So when I do that, that adds to be 0. I'm left with d equals. I can write this as f plus e, or I could say that it is e plus f. Those are equivalent. Now this is adding and subtracting. We can move down to multiplication and division. Go ahead and solve these two equations right now based on the inverse operation method that we talked about earlier. Now that you've tried this one on your own, let's talk through it together. If I'm solving for x, that means I need to get x by itself. Well, right now I see it's negative 6 times x, and the inverse of multiplying by negative 6 would be dividing by negative 6. So I divide both sides of the equation by negative 6. Negative 6 divided by negative 6 is 1, so I get x equals, a negative divided by negative is a positive 5. If I use that same method down here to solve for r, I'm saying, okay, well, I'm solving for r means I need to get r by itself, which means these need to move to the other side. Well, right now, this is c is equal to 2 pi times r. So I can do the inverse of multiplying by 2 pi, which is dividing by 2 pi. 2 pi divided by 2 pi is 1, so on the right-hand side I'm left with 1r, or just r, and on the left-hand side I have c divided by 2 pi. If we look up here, if I'm solving for y, means I need to get y by itself. Well, right now it's y divided by negative 4. So I'm going to do the inverse of dividing by negative 4 and multiply both sides by negative 4. Negative 4 divided by negative 4 is 1, so I'm just left with y equals negative 32. If I look at this literal equation, where I have more than 2 or more variables, I now want to solve for m. The setup is very similar. I need to get m by itself. Well, right now I'm dividing m by v. To do the inverse, I would then multiply by v on both sides. And v divided by v is 1. On the right-hand side, I'm left with 1m, or just m. And then on the left-hand side, I'm left with v times d. I can write my answer as v times d is equal to m, or m equals vd, or m equals dv. When you multiply, you can multiply in any order. These are all equivalent. Now I can do the same thing for two-step equations. Two-step equations require more time, though, or more steps, obviously, too. So looking at 5, I'm solving for w. I want you to try this one on your own before I tell you or talk through how to do it. So try and think through, what could I do to get w by itself? Pause the video and try on your own. Now that you've tried on your own, let's work on this together. I want to move this 2L term to the other side. So because it's a positive 2L, if I subtract 2L from both sides, these will add to be 0. On the right-hand side, I'm left with 2W. And on the left-hand side, I have P minus 2L. I have not solved for W yet. If I solve for W, it means I've isolated W, and W would be by itself. But I have 2 times that. Well, the inverse of multiplying by 2 would be dividing by 2. When I divide by 2 on the right-hand side, I also have to do it to every term on the left-hand side. 2 divided by 2 is 1, so on the right-hand side, I'm left with W. On the left-hand side, I can leave my equation like this, and I'm done. I could also divide each term in the numerator by the denominator. And if I do that, I could simplify. Now, P over 2, I can't really simplify. You could write it as 1/2 P. Minus 2 over 2 is 1L. So I could say that, or just 1/2 P minus L is equal to W. This is another way I could write my answer. Both ways would be correct. For 6, if I'm solving for B, I want you to pause the video and just think through, what could you do to solve for B? Think through it on your own before watching the rest of the video. Now that you've tried this on your own, let's talk through this together. I have this 1/2 and the h I need to get rid of. Now, if we have 1/2 times b, we've talked through doing this in a couple different ways. One is to multiply by the reciprocal, or we can just think through, if we're dividing by 2, the inverse would be multiplying by 2. So I can multiply by 2 on both sides. On the left-hand side now, I'll have 2a. And if I have 2 over 1 times 1/2, that's just 1. So 1b is just b, and then I still have times h. There was no multiplication symbol written there, but it is implied when they're next to each other. I still have not solved for b yet. I need to move that h to the other side. So I see I'm multiplying by h. The inverse of multiplying by h is dividing by h. H divided by h is 1, so I'm left with 1b, or just b. And over here I can have 2a over h. I can't simplify it at all. I just leave it like that. So b is equal to 2a divided by h. Moving on to number 7 and 8. I'd like you to pause the video, try these on your own, and then see how I do the problems afterwards. So pause the video, try on your own now. Now that you've tried this on your own, let's talk through this together. If I'm solving this equation for L, I'm going to circle what I'm solving for. Everything else needs to move to the other side. I do this using reverse order of operations. So if I'm adding pi r squared, I can subtract pi r squared minus pi r squared. Those will add to be 0, and on the left-hand side, I can't combine these, so I just write it as s minus pi r squared equals pi r L. Now when I just say pi r L, we're implying that we're multiplying pi r times L. So to do the inverse, if I want to get L by itself, I could divide by pi r. And if I divide on the right-hand side by pi r, I also have to divide on the left-hand side by pi r. Anything divided by itself is 1, so on the right-hand side I'm left with 1L, or just L. And on the left-hand side I'm left with s minus pi r squared over pi r equals L. Now, if you want to divide each term by pi r, you can, and then you can simplify it. We have not done that kind of simplification in this class yet, so I'm just going to leave the answer like this. Finally, over here for number 8, if I'm solving for w, it means I want w by itself, so I need to do inverse operations to get it by itself. We talked about in class how there's imaginary parentheses here, so I really need to take care of this dividing by m first. The inverse of dividing by m is multiplying by m. So those divide out to be 1. On the left-hand side, I have m times s, or s times m. It doesn't matter. On the right-hand side, I'm just left with the numerator. I'm still solving for w. So now, the inverse of subtracting 10e would be adding 10e. And if I do that, now I have w on the right-hand side by itself. I have m times s plus 10e, or my final answer could look like this. W equals m times s plus 10e. You could also choose to write your answer as sm plus 10e. You could write this with 10e plus s times m. Lots of different ways you could write your answer. These are all equivalent. They would all get full credit on the quiz or test. So these are examples of literal equations. Equations where you have 2 or more variables and you're solving for one of the variables. Use this now to solve other literal equations.